Plant breeding programs, farm machinery, chemical inputs, processing and marketing chains, the way we eat, it's all co-evolved to support monocultures. Meanwhile, science is showing that this simplification of agricultural landscapes is causing major environmental problems. Water pollution, soil degradation, biodiversity loss, pest and disease outbreaks, these can all be linked to huge fields of uniform crops managed in an input-intensive way. Pixel farming is a response to mounting concerns about the impacts of industrial farming methods. It's basically an anti-monoculture. Pixel farming is a crop management concept that mobilizes diversity and ecology instead of chemical inputs, and treats variability in crops as a good thing rather than a problem that needs to be smoothed over. Pixel farming offers opportunities to grow food in a way that not only doesn't do harm to the environment, but even does something good for it. Growing a lot of different plants in the same field requires a different approach than what most farmers are used to. In the past, it was more common to cultivate diversity on farms. For example, Mayan farmers practiced what they called the Three Sisters, where corn, beans, and squash mutually supported and nourished each other. There's a lot we can learn from indigenous systems, but there are still a lot of things we don't know, things we really need to know if we want to design diverse farms that can simultaneously feed the world and save it from environmental collapse. For one, we need to know what's happening below ground when a lot of different plants grow next to each other. Roots interact and communicate in ways we're only starting to understand. Above ground, things are equally complicated. A potato plant behaves differently when it's grown next to a cabbage than when it's grown next to barley. And possibilities for how to design plant neighborhoods, who's planted next to who, are practically endless. We also wonder about what these plant jungles offer to our insect friends. Ground beetles do good things for our system, like eat weed seeds and pests, and we want to know if they like living in our pixel plots. One of the biggest questions we have about pixel farming is how to manage the labor. For now, everything is done by hand, because machines that can handle the complexity and fine resolution of our fields just don't exist yet. Asking people to design machines that work for ecology instead of against it challenges the industrial paradigm. We dream about eco-friendly robots who will one day do the job for us, but this dream is complex and problematic. If you were a pixel farming robot, would a hare running through the field scare you? Or would you scare the hare? Could you stand still enough to catch a wasp in the gruesome act of penetrating its caterpillar prey, fat and drunk on leaf juice? Would you hear the cabbage cry for help and know what to do to protect it? Could you understand the languages of soils and weeds? Could you dig sugar beets and carry them home to the barn on your back? Would you feast on the harvest with your human companions? Could you?